My name is Clara, and I'm from Edinburgh, and this is some work that I've been working on last summer with Ed Mitchett, who unfortunately can't be here today, but he trusted me with giving this presentation, and I hope that by the end of it you'll still agree with him that this was a good idea. So the first thing I should tell you is that the title of this presentation changed slightly. So for anyone who came here because of Modus, sorry to disappoint you. So this is kind of the outline of my talk. I'm just going to give you a little bit of background before I tell you about some of the methods, what we found, which problems we encountered, the discussion, and the conclusion. So the area that we are interested in is the forest-savanna boundaries that occur in large parts of Africa. So if you look at this map, you can see that there's this tropical evergreen rainforest in the middle, and the deserts at the top and bottom. And here, in these areas where there isn't any rainforest or evergreen rainforest or desert, there's a mix of seasonally dry tropical forests and savannas. And so in many parts they built this mosaic, which is a kind of mix of where you can find these boundaries between the savanna and the forest. And just to give you some definition, so forest, we define forest as being trees with a closed canopy, and savannas are mixed tree grass systems. So it doesn't mean there aren't any trees in there, but it's not a closed canopy, basically. And this is just to illustrate. So here's some savanna. This is what we would call forest, and here you can see this kind of boundary where you can clearly see that there's some quite dense forest bordering the savanna. So with these mosaics, if disturbances arise, the trees or shrubs can encroach into the savannas or vice versa, because they're in a continuous flux. But over the last decades, definitely, there's been a growing body of evidence that there's woody encroachment, so encroachment of forest into the savanna happening across large parts of Africa and also in other parts of the world, but we were just focusing our research on Africa. But the problem with this is that no one has really collated all the reports, so we don't really know at what scale and to which extent or magnitude this is happening. And the justified question is, why don't we know the answer already? Well, in our opinion, there are two main problems for this. So the first one, which is also mostly related to this talk, is that it's only detectable over longer time spans. So you need a way to map the changes in woody cover over a long time to detect any changes. And secondly, it's also quite underreported because most efforts are directed at detecting forest loss. There's more kind of international attention on forest loss, and there's also some fear that certain groups might misuse information about reforestation or wood encroachment to say that everything is fine and you can just fell the trees, basically. So our two main questions were question one, how widespread is woody encroachment in Africa? And second question was, how much encroachment is there compared to forest degradation and deforestation? And to tackle all these questions, we decided on two different approaches. So the first approach is a classic literature search to determine in which regions woody encroachment has been reported. And the second one is the use of a long-term recording of changes in woody cover on the whole continent to answer both of these previous questions. And we found this record in the IGARSS GIMS dataset, which covers the time span of 24 years from 1982 to 2006. So just a bit about this. IGARSS is the Advanced Very High Resolution Radiometer. It's carried by many, 11 different satellites, NOAA 6 to NOAA 16. And it's quite a coarse resolution, so to save archive space, the effective pixel size is 1.1 times 4 kilometers, and there's a 3 kilometer gap to the next pixel. So the data taken from these from the AVHR has been collected in a product called GIMS NDVI, so Global Inventory Modeling and Mapping Studies. And this is a product that has been corrected for calibration, view, geometry, volcanic aerosols, and other effects that are not related to actual vegetation change. And it gives us an estimate twice per month. As you all know, the problem is that NDVI doesn't equal woody cover. So NDVI records all live vegetation, which would include grasses. But because we're only interested in the woody cover change and not in the grasses, we needed to find a time where we could exclude grasses from our analysis. And one approach is to use the average of the 3 months period with the lowest NDVI, which is the end of the driest season, because in that time most of, hopefully all grass cover is dead, so won't be recorded, and there are some trees that have either retained their leaves or already growing new trees because of the approaching wet season. So, and this approach has been used in several studies, one of which was one that Edmund was involved in, and they have found a good concordance between this dry season NDVI and woody encroachment. And the thing is, as you can see in this graph over here, it's not just that dry season is kind of more suitable because you can, let me put it this way, so NDVI here and the time here, and you can see that whereas the average and wet season, you can't really detect any change in this in the study site they were looking at. Only the dry season NDVI shows this change of, or shows this encroachment and increase in NDVI. So I hope that made sense. Oh yeah, and also the signal was replicated in higher resolution datasets, so raster and Landsat. So just quickly the methodology, which was actually quite straightforward. So you can download the GIMS data set for free, and it's pre-processed and corrected. So you don't have to worry about it that much. The next thing we did was calculate the mean NDVI for every possible consecutive 3-month period for each pixel from 1982 to 2006. And then we extracted the minimum 3-monthly NDVI for each pixel for each year. And sort of quality control, we only 3-month periods where 5 out of 6 possible observations reached this best quality standard were considered. The next thing was to perform a linear regression across each time series for each pixel. And the change in woody vegetation considered to have occurred. You can read this for yourself, but the point is that this suggests a change of 0.05 NDVI units in total over the 24-year period. And I'd like to add that these thresholds are arbitrary and were chosen based on the literature and visual assessments of the maps. But so they could be refined, but if you have a better ground data set. But we thought they represented the areas where there's a strong signal in the data quite well. So, the last step was to remove pixels containing no wooded classes or close evergreen lowland forest, because these, there could be signals coming from grass or from cloud cover, contamination, and phenology. So we excluded these as well. so what did we find? Based on the literature review, we found 16 studies where woody encroachment has been detected in 8 countries, and these include Cameroon, the Republic of Congo, Ethiopia, Gabon, Ivory Coast, South Africa, Swaziland, and Uganda. And these studies span, studies span a wide range of ecosystems and rainfall levels. And just to stress as well, this was not comparing deforestation versus encroachment. We were just looking specifically for studies that reported woody encroachment, just to get an idea of the kind of spatial extent of this phenomenon, and to confirm that it's not confined to certain geographical areas. And the result of the NDVI mapping was that woody encroachment and forest loss are both occurring, and that 4% of forest savanna mosaics show a significant positive change, or 4% of all the things we looked at showed a significant positive change in NDVI, whereas 3.25 showed a negative change, so you can see it's quite 50-50. And the second thing, which was quite interesting, and which we couldn't find just from the literature search, was that there's actually quite strong spatial patterning. So the majority of encroachment has happened north of the equator, so that's all the dots in green. There's some here as well, but yeah, the majority happens up there. And whereas the majority of loss has occurred south of the equator, especially in the Miombo woodlands, which are here. So that's interesting. Obviously, there are some issues with using this type of analysis. So, for example, there could be artifacts in the GIMS dataset. But as I said before, it is this dataset already, like, it's an attempt of a clean, like, it's already removed certain, things that could have affected the data, but there's still, obviously, still probability that due to some resampling and cloud filtering algorithms, there could be some artifacts present. Also, the regional variation in relationship between NDVI and woody cover is a bit uncertain. So, for example, in West Africa, signals in NDVI datasets appear to be more related to grass fuel loads rather than tree cover, which is also why we excluded West Africa from our analysis. And obviously, we don't really know how, like, if this is also the case in other parts of Africa. So that's something that definitely needs to be investigated. Of course, because of the coarse resolution, the GIMS approach does not discriminate between vegetation classes, but only detects woody cover change over 8 kilometer pixels. But we try to account for that as well, because despite most of these pixels being mixed pixels, the results should be robust if the ratio of forested to non-forested vegetation in the pixels changes significantly. So, just quickly, so what could be the causes? So the general opinion is that it's hard to underestimate the anthropogenic influence on Africa's forest cover. And there's a variety of factors that can lead to woody encroachment. One example is increase in grazing pressure, because it reduces grass fuel loads. So there will be less frequent fires, and trees don't cope as well with fires as grasses. So the kind of sapling mortality reduces if there are less fires. Related to that is the expansion of road networks, because roads create fire breaks, which again leads to less frequent fires. You can also see that these don't only affect encroachment directly, but that grazing also affects fire frequency, which affects encroachment. So there are lots of different relationships between these factors. And a more global factor is atmospheric CO2 enrichment. This is because atmospheric CO2 enrichment reduces the advantage held by C4 grasses over C3 trees, because C4 carbon fixation increases the CO2 concentrations in the cell, but it's a limitation for photosynthetic efficiency in high temperatures. But now, since there's much more CO2 anyway, the grasses lose this advantage. So, but what the main driver or main drivers are, I don't think anyone has tried to look at this using a scientific approach. Oh, well, there are, but there's no consensus. We should put it that way. So just to conclude, we found evidence for widespread woody encroachment in sub-Saharan Africa, which at least equals the extent of forest loss. We demonstrated the feasibility of using large-scale dry season NDVI data to detect changes in woody cover. We detected a spatial separation of high forest gain in northern Africa and high forest loss in southern Africa. But there's definitely a need to improve the understanding of the relationship between dry season NDVI and woody cover. Thanks for listening. Thanks to my co-authors and all the other people for data and advice. And if you have any questions, you could read the paper that this presentation is based on, or email Ed. And I will also try to answer any questions, but I can't promise too much. Thank you.
Okay, thanks for the presentation. Actually, the GIMS NDVI is a very good long-term archive data to study the continental to the global scale. And because of it's very, very coarse resolution, So I think it would be better if you use some image with more fine resolution to test your findings. It's just a comment. And a question. You're looking for a lot of literature to get some information for the increment, right? So the inside study can support your findings.
Which studies? Just the literature?
I mean, some report from the literature, can support your findings in this area.
Yeah, well, there are lots of there's a lot of literature reporting kind of local encroachment in all these different parts. So the map I showed you before. So just 1 second. Yeah, this one. So the pink dots are all the places where woody encroachment has been reported. So, but I think this is the first time, well, I know of anyway, that someone has looked at the whole continent. So, yeah, I don't really know if I don't know of any other studies that could support the findings.
Yes, I hope all the literature can support your findings. Okay.
I just want to say your first comment with the coarse resolution. I think the reason we used this data was because there wasn't any other data, more high-resolution data available for such a long time span, and we needed to look at it over a really long period of time to be able to, reliably assess the changes. So.
Yeah, because from your result, so the coverage changed better in the northern equal, right?
Yeah.
And decreasing in the southern equal.
Yeah.
So actually, you found a lot of literature from the situ research.
Mm-hmm.
So I don't know whether you compare this result.
Okay. Sorry, I'm not really sure what you mean, but I think.
Okay.
Sorry.
So a lot of findings you you can get from the literature.
Yeah, yeah.
So, I mean, all this literature can support your findings in your research?
Well, yeah, I mean, I think there has been other literature as well which might refute this, woody encroachment, or it's quite a disputed issue, I would say, but because we're only interested in literature that reported woody encroachment, we can't really say anything about other literature saying it's not.
Okay.
Sorry.